Alright guys, this is take number 2. I am going to do just pages 28 through 30. In this first video, I'm going to go ahead and break it down into each topic this time, instead of trying to do all of it at one time. I tried to do it in halves a while ago, and I ended up losing my video. I don't know what I did to it. We're going to pray to God that this works. Okay, everybody cross your fingers. Okay, I did figure out a little something that's going to help things go a little bit faster. I was able to write out some problems, so we're going to go through this again as page 28 through 30. Okay, page 28 through 30. We're not going to look at all of them. We're just going to look at a few. So we're going to do number 4, number 6. We're going to do number 8. We're going to do number 10, number 14, number 20, and 26. Okay? So I was able to figure out how to put slides in so I could write all those out, and we don't have to spend time with erasing and all of that. Okay, let's do number 4. First of all, remember that for an equation to be a function, we talked about the fact that it had to follow what I like to call the Highlander rule. Okay, and remember that says that for every x there can only be one y, right? So there can only be one. Now, when we see a series or a set of points, we can't do our vertical line test when we're just looking at points. So we're going to, I'm pulling up a different color here. No, let's do blue. We're going to look at the x's. Okay, you can have repeats in the y's. For every x, there can only be one y. But we can have more than one, an x can have, a y can have more than one x. So we can have repeats in the y's, but we cannot, no repeats in x. Okay, so no repeats in the x. So we're looking to see, is there a repeat in our x values? We have a 10, we have a -10, we have a 6, a 5, and a -6. No repeats. So is this a function? Yes, this is a function. Okay, now with our domain and our range are going to be, when we've got points, when they give us just points, not a graph, not a continuous graph, we're going to list each individual x and each individual y. Okay, but we won't have any repeats. So we're gonna start with our smallest x. Okay, going least to greatest. So we're going to start at -10. And then we're going to go to -6. Then we're going to go to 5. Then 6. And then 10. So there is our domain. Okay. How about our range? Well, like I said, we can have repeats in our y's, and that's okay, but we're only going to list it one time. Okay? Excuse me. So we've got 2's. We've got a 3. We have a 4. And we have a 7. So for this set of points, our domain is -10, -6, 5, 6, and 10. And for our range is 2, 3, 4, and 7. Okay. Now, let's look at number 6. Number 6 had a graph with some points. And in this case, since it's a graph, we can do the vertical line test. Remember that? We take a vertical line and we draw it down. And if that vertical line hits only one point, okay, anywhere on that graph, if we hit any point just one time, then with one line, then it's a function. But if it crosses twice, then it's not a function. So let's take a look. With our first line here, we hit 1 point, right? Okay, so far so good. Second line, we hit 1 here and 1 here. And because we hit it twice, it does not work. So, is this a function? No. Okay. If we looked at other points, they did only hit one time. But all it takes is that one line to throw things off. Okay? Alright, so what's our domain and our range? Our domain, again, x values. We're going to start at the low end and go to the high end. And we're going to name off our points. So we've got one at -1, 2. So -2. We've got -1.5. We've got them at -1. We've got them at 0.5. We've got them at 1, 2, and 3. Those are our x's. Our ranges start at the low value here, go to the high value up here. So we have at -1, 2, 3.5. So -3.5. Okay. And then we go up to -0.5. Then we go to 0. And we go to 0.5. Then we go to 1.5. And we go to 2. And 2.5. Okay. Hopefully that didn't confuse you with it running into our page numbers there. Okay, let's go to our next equations. I am so sorry I'm yawning so bad. Okay. Here, we're going to take, we have f of x equals -x plus 4. And we're going to take our x's and plug them in for x, okay? So here we have negative, and then our x is -2 plus 4. When I subtract a negative, it goes click, click. So I have 2 plus 4 is 6. Okay? Okay. Then we have -0.5 plus 4. Again, do our click, click. So we end up with 0.5 plus 4 gives us 4.5. Okay, and one more. We have negative x is 3 plus 4 gives us -3 plus 4 or 1. Okay? Those should be easy enough. All you have to do is remember that this is your x value. It's f of x. So if I have a number in for my x, then that's the number I'm going to place right here for x. Okay? All right. Easy enough. Now, we have x. This is number 10. it says to find the domain, the range, and the intercepts. So we need the domain, we need the range, and we need the x-intercept and the y-intercept. Okay. All right. We're going to start and we're going to solve for y, right? We're going to start to solve for y, so we're going to move x over. So we have 3y equals negative x minus 1. To get y by itself, we then have to divide by 3. So we end up with y is equal to negative 1/3 x minus 1. Okay, now let's get some points here. All right. This is y equals mx plus b. Remember, b is my y-intercept. M is my slope. Okay? So, my y-intercept... Oh, I didn't... Yeah. Oh, I know what I did wrong. I didn't finish writing out my problem. Negative 1/3 x minus 1/3. I so apologize there. Okay. Put my point there. That's my y-intercept, right? That's my negative 1/3. Okay. Now I have a negative 1/3 slope. That negative tells me I'm going to move down. And then I move to the right. So rise is a negative. So I go down 1 over 1, 2, 3. Oops. There, close enough. Okay. And then go back to my y-intercept and go up and over to the left 3. And right there. Okay. So... that gives us a line that looks if I can get it right. There we go. Close anyway. Okay. Now, my domain. My domain let's come over here and write this out. Okay. My domain, as I go down, everything goes to the right, right? And as I go up, everything goes to the left. So all the x values that I hit is all real numbers. So negative infinity to infinity. Okay. Now, for my y values, as I go to the right, I go down. And as I go to the left, I continue to go up. So for my y values, again, my y values in my range end up hitting all real numbers. Okay? Alrighty. Now, I can look at my graph and I can see that my y-intercept, I can actually get it right there from my my formula. My y-intercept is negative 1/3. Or you could write it as 0, negative 1/3. Okay? My x-intercept. my x-intercept, I can look at the graph and I can see that right here it crosses at the 1. Or I can take and I can put 0 in for y, and I can solve for x. Negative 1/3 x minus 1/3. When I add 1/3, I get 1/3 is equal to negative 1/3 x. I multiply by negative 3. I end up with negative 1 is equal to x. Okay, so you can either look on the graph or you can do it algebraically. You can do it algebraically. Okay, this is getting frustrating because I keep pausing my videos. Okay, so we can look at the graph or we can look at it algebraically. Either way, we end up with an x-intercept of negative 1. Or you could say negative 1, 0. Okay? Alright. Let me get away from that slide before I get frustrated with it again. Okay, number 14. Number 14. Come on. Now, f of x equals 2/3. Okay. Now let's take a look at a t-chart. Okay. If I have an x and y t-chart, and I have, let's say, 3, 1, 0, negative 1, negative 3. If x is 3, my y is still going to be 2/3. If x is 1, y is going to be 2/3. If x is 0, or if it's negative 1, or if it's negative 3, regardless of what my x is, because there's no x out here, it's just a constant. That means that whatever my x is, my y is going to be 2/3. Okay? So, we come over here, and at 2/3, and at 2/3, and at 2/3, whoops, 2/3, well, that's getting closer. There we go. And that's not 2/3. There we go. Okay, there's 2/3 at all of our points. Okay. Okay, and we draw our line and pretend that's a straight line. Okay, so this asks us, what's our interval? What's our interval for negative infinity to infinity? What's our minimum and maximum? So what's the minimum and what's the maximum? Okay. Well, good question, right? As I go out to the right and I get bigger towards that infinity, I go towards my maximum, right? And because it's a straight line, there's no curves, right? It stays the same. So my maximum, however far out that goes, right? That's going to end up being what? 2/3. Okay. How about my minimum? My minimum is as far out as it goes to the negative side. But what happens? It stays at steady 2/3. So my minimum is also 2/3. Okay? Alrighty. Y'all will get to do number 16 on your own. If you have questions, you can ask me. Come by and talk to me tomorrow. Okay. Let's look at number 20. 20, fairly straightforward. This just says f of x plus g of x. Okay, f of x was x minus 4. G of x was x squared minus 16. We're going to combine like terms. Okay, and if there's not a term like it, we're just going to add it. It's just going to be part of the overall equation. Okay, so I have an x, I have a negative 4, which is a constant, I have an x squared, and I have a negative 16 that's a constant. Okay, I only have one x squared, so I'm going to write x squared, and I'm done with that. Then I have an x, that's a positive x, so I put plus. Now I'm done with that. Now I have negative 4 and negative 16 as constants, and I'm adding them together. So, negative 4 plus negative 16 is negative 20, so I'm going to write minus 20. And there's my answer for adding those two binomials together. Okay? Alright, let's look at number 26 real quick, and then we'll be done with this part of the video. Alright. We have g of h of 2. Okay, now I said g of x was 5x minus 2. I said h of x was x squared plus 1. This is where we did our boxes. Do you remember our function machines that we did? Okay, remember that our x goes right here. Okay, so whatever's in that x part, that number, that goes in our top box. Then we go to the letter that's closest to the x, and that's h of x. And then we go to the next letter, that's g of x. Okay, and we write that in. 5 times x minus 2. And I have x squared plus 1. Okay, so now we've got all the components in our function machine. We have our input 2. So we're going to input that into our equation for x. Okay. Oh, and I just did that backwards. Excuse me. Let's take all that out. I wrote those backwards. Okay. X squared plus 1. And then g of x is 5 times x minus 2. I am so sorry. Okay, I'm getting tired. Okay. H of x is x squared plus 1. I take my x, which is 2, and I input it into the x in h of x. Okay? So I have 2 squared is 4, plus 1 gives me a total of 5. So my output is 5. Now my 5 gets input here. Okay? So put a 5 here. 5 times 5 is 25. Minus 2 gives me 23. So, g of h of 2 is equal to 23. Okay? Remember that for your test tomorrow. When you're doing composition of functions. Okay? All right. And that is all that I'm going to go through with you on topic 1. Okay? Remember, there's still a few others that I did not go over, so make sure you get those done. And I'm going to go try to post this video, and hopefully I don't lose it this time. Thanks. Bye.